Dear students, first of all, turn on your videos first. All students, first of all, turn on your videos. Okay. Lokra sir,
Sir.
sir, you can start, sir.
Yeah, please. Okay, sir.
Slowly start, sir. Some students join slowly. Okay, sir. Still time is 7:33.
Okay, sir. Okay.
Okay, sir. Wait 2 minutes, sir. 7:35 start, sir.
Okay, sir.
35 students came, sir. Remaining will join, sir.
Okay.
Okay, sir. Okay, thank you, sir. Some students are only enter your name only.
All of you, please rename yourself, everyone. So already instructions given by our program coordinator, sir. Okay, please follow according to just given instructions. Yeah, I will continue the just listen. In the previous class, I have discussed about center of mass. Center of mass.
Sir, 1 minute, sir. No crash, sir. 1 minute, sir.
Yeah.
1 minute. All students, first of all, turn on your videos, please. Only few members only on no videos. Remaining all close your videos. First of all, turn on your videos. All students, please turn on your videos. Okay, sir. Carry on, sir. No crash, sir.
Okay, sir.
Okay,
Okay, sir. Right, sir. Right, sir. Thank you. Students, is it visible? And just am I audible by voice?
Yes, sir.
Yeah, very good. Okay. Now, just in the previous class, just what we have learned, especially I just introduced the center of mass and how to just locate the center of mass. In just the first class, just given just how to locate the center of mass for uniformly distributed bodies and also non-uniformly distributed bodies. In the second class, just I just introduced how to calculate the system of center of mass of system of particles. About just 1D, about just 2D, about just multiple particles also. So in this session, just I want to discuss about position of center of mass. Position of center of mass. That means position vector of center of mass. Position vector of center of mass. So every student, please try to understand what I'm just going to explain. Just I given first of all theoretical part. Immediately, just for better understanding, just I want to give the numerical examples or problematic. So please follow this manner. This is very useful to you. Okay. And coming to the next one, position vector. Position vector of center of mass. Position vector of center of mass. Right? So already we know the just vector concept. In the previous class, that means in the 8th standard, in the C batch as well as icon as well as just medical also there, vector topic. So what we have learned in the vector topic especially related to our topic, just I want to give just one point. What is position vector? What is a position vector? For example, this is a combination of two mutually perpendicular axes. Two mutually perpendicular axes like x and y combination of axes. So this is origin. This is origin. Now, if I consider just the particle position is equal to this is the particle position, like P, like P. Now, just how can you write just the coordinates of this particle is x, y, because of this is one coordinate, this is another coordinate. That means this is one axis, this is one more axis. So along the x-axis, I consider just x. Along the y-axis, I considered y. So about just the particle position equal to the coordinates of the particle equal to x comma y, x comma y. So according to given diagram, just I want to develop the position vector. What is the meaning of position vector? A vector which is drawn from the origin. A vector which is drawn from the origin into the just given plane is called position vector. Generally, position vector is indicated by r bar. Generally, position vector is indicated by r bar. Along this one, so along x-axis, what is the unit vector? I cap. Along the y-axis, unit vector equal to j cap.
J cap.
J cap. Now coming to the point now, r bar simply can be written as xi cap plus yj cap. About just 2D. If you consider the 3D also, you can write r bar equal to xi plus xi plus yj plus and zk also. So this is the information about position vector in plane as well as space, right? So this concept is very useful to explain the position vector of center of mass. Position vector of center of mass. Please try to just make a note down. And coming to the next one. So how can I understand the position vector of center of mass? Position vector of center of mass. I want to give the just one diagram for better understanding. Now here, this is their x-axis and also this is y-axis. You can consider just a z-axis also, no problem at all. Z-axis also. Now just I want to consider the some position vectors in a given plane. Like for example, this is origin. This is for example, if you assume just this is the M1 particle. This is M1 particle. Where is the M1 particle actually? In the distance of R1 bar. In the distance of R1 bar. And coming to the next one, I want to consider just one more particle like M2. Where is the M2 bar? In the distance of R2 bar. And similarly, and so on, Mn, and so on, Mn. So what is the distance of this one actually? Rn bar. Rn bar. Is it clear?
Yes, sir.
Okay. So if you assume just a center of mass in this one actually, if you assume just a center of mass in this one, so we can write just this is the center of mass. I'm just writing simply Cm. What is the distance? RCM bar. RCM bar. Is it okay? Now here, just from the diagram, just we can understand very easily. So here, where is the just different massive bodies located in the just given area? So like M1, M2, M3, M4, and so on. M1 particle just I considered in the displacements of R1 bar, R2 bar, R3 bar, R4 bar, and so on, Rn bar. But I assume and just consider center of mass is lie in the boundary of given just a plane or space. I said already that point. I just stressed that point also in the previous class. Now here, center of mass is just lying here. If you assume the center of mass here, what the distance from just object to just given center of mass? RCM bar. RCM bar. So for this situation, how can we calculate the center of mass of the given system or position vector of center of mass? Position vector of center of mass. Now coming to the point now. Now here RCM equals to, so we have just for two particle system center of mass formula M1 x1 plus M2 x2 plus M3 x3 plus and so on. If you consider number of particles by total mass like M1 plus M2 plus M3. So similarly here also I considered M1 R1 bar plus M2 R2 bar plus and so on. I'm writing totally Mn Rn bar whole divided by total mass M1 plus M2 plus and so on Mn particles. Is it okay? So this is about position of what we call this one, position vector of center of mass. Position vector of center of mass. So this is the formula. So this is the formula. I want to develop just a general formula. Now here RCM equal to RCM bar equals to. So in the previous class also I considered sigma I value from just 1 to n. Similarly, just I follow the same manner. Now here sigma I equals to 1 to n mi, and come to the next one ri whole divided by sigma I equals to 1 to n total mass. In some books written capital M instead of this total mass. So I want to consider just here also mi. So this is the general formula. This is the general formula for the given position vector of the center of mass. Please write information. Write this information. So have any ambiguity in the given explanation? Try to answer. Okay, try to ask this one. Right? Just this is the information regarding the position vector of center of mass. If you understand this information, we can solve a number of related problems. Right? Are you getting my point, everyone?
Yes, sir.
Yes, sir.
Okay. Are you following clearly?
Yes, sir.
Very good.
Yes, sir.
Can I Rabdi?
Yes, sir.
Okay, okay. Everyone, please write down. Don't be lazy. Once again, please write down. If you are writing, you will get the just information with clarity. Right. Next one is very, very important concept. That is change in. This is very, very important concept. Change in. Similar, same manner. Change in position of center of mass. Change in position of center of mass. This is very important. Just in this case, I want to use the calculus like differentiation. I said already to prepare well about calculus, both differentiation as well as integration. Are you preparing? Did you prepare?
Yes, sir.
Okay.
Yes, sir.
Formless enough. Okay, right. So can you explain now? Just I considered again two particle system. Again two particles. So like M1. This is M1 particle. And coming to the next one, this is one more particle I want to consider. M2 particle. M1 and M2. So this is M1 and this is M2. M2. So these two are separated by a certain distance. Just assume this is the object. Just from starting onward, just I follow the same example without any ambiguity or confusion. Okay. Now this is the object position. From object to first massive body, like M1, I consider the distance equal to x1. Similarly, from object to M2, like x2. Just assume the just center of mass lies in between these two. For example, if I consider just this is a center of mass. For example, this is a center of mass, like CM. This is a center of mass. Right? So for the two particle system, we know the center of mass. Along the just one direction. Now XCM equal to M1 x1 plus M2
X2.
whole divided by M1 plus M1 plus M2. Okay. Now here, just I want to just differentiate this function. Differentiate XCM. Differentiate XCM. Right. Just I want to differentiate. So differentiate of XCM. Just I want to use one important just symbolic representation, that is delta. Here delta represents a differentiation. So already xn is just a large value. If you are going to just differentiate this function, you will get a very small value. That is nothing but we are just simply indicated as a delta. Now here delta xcm, delta xcm, xcm differentiation delta xcm. What is the meaning of delta xcm? Displacement of center of mass. Displacement of center of mass. Just I got to write first out. M1. Here masses are constants. So there is no any change in the massive bodies. So only just the displacement position must be changed with respect to given function, whatever it may be. Now M1 into what about X1? Delta X1.
X1.
Yes, exactly. Now M2 into
Delta X2.
Delta X2.
Very good. By total
M1
mass.
plus M2.
M1 plus
This is very important formula. Excellent formula in center of mass. Then just we have to give just a symbolic representation like delta xcm, displacement of xcm or center of mass simply. Center of mass. Right, and the just a symbolic representations also will give the complete clarity. And come to the next x1, delta x1. What is delta x1? Displacement of m1 particle. What is delta x2? Delta x2 is nothing but the displacement of like m2 massive body. M2 massive body. Are you getting?
Okay, sir.
Now here very important point is there actually. Actually this is the concept of relative motion. Concept of relative motion. But in this case just I want to fix one point, one massive body. So just I want to just move another massive body with respect to given object. Is it okay? Now coming to the point now here. So you have to just identify the terminology. So what is xcm? What is delta x1? What is delta x2? What is delta xcm? So naming is very important. And coming to the next one, just here I want to fix any one massive body. For example, here I want to fix this point. This is fixed. So this is my convenience. That's why just I want to just fix the M2 massive body. M2 massive body. So what happens? What happens? I want to give. Now here, try to understand. This is completely fixed. This is completely fixed. So which one is moving from the object?
M1.
M1.
M1 massive body is just moving towards M2 body. Otherwise, away from the M2 body. Possibilities are there. So first towards object, away from the object. For example, just I want to give just one notation here. If I give the just one notation. If M1 moves, M1 moves towards M2. Towards M2. What happens? Tell me now. Towards M2, what happens?
Mass changes.
If M1 moves towards M2, what happens? I mean just what about delta x1 and what about delta x2? M1 means M1 related displacement is delta x1. What is the nature of delta x1? I mean just whether it is negative or positive. When it is negative, when it is positive. That is the meaning.
M1
Yeah. If M1 moves towards M2, M1 moves towards M2 means this is the momentum direction. Okay, now M1 just very good, excellent. Closest to M2 is what is the distance from the object? Increases is nothing but a positive sign. Increases simply we can write delta x1 is positive. Very good. First. Right? Similarly, if M1 moves away from M1 moves,
Negative.
Negative.
yeah, very good. Move from M2, so therefore delta
Delta
x2
X1
is
is negative.
negative. Excellent, very good. Right up.
Sir, can you again repeat, sir? I don't understand.
Yeah, I got to repeat. No problem. Yeah, please first of all write down. Again, I will repeat. Can I explain?
Yes, sir.
In this situation, I want to just restrict M2 body. Restrict means fixed. Restrict or constrain an M2 body. Only M1 body just moving from the object towards the M2 body. Right? Now here, if M1 body, this M1 body moves towards M2, what happens? Gradually distances increases from the object. So here, who is reference here? Object is reference. This is a frame of reference. Okay. Here, frame of reference is object. So with respect to object, what happens? The displacement gradually increases with respect to just object and as well as M2. Should be clear?
Yes, sir.
Yeah, coming to the next one. So coming to the second condition. So here x1 automatically the distance gradually increases for the first condition. Coming to the second case. So here m1 just traveling away from the m2 as well as reaches to the object. Reaches to the object. What happens here? Gradually the distance must be decreases. Gradually the distance must be decreases. That's why. So here negative sign indicates just negative sign indicates distance gradually decreases. So in the second case, delta x2 is equal to negative because of the distance from the m2 okay now decreases towards the object. Is it okay?
Yes, sir.
Everyone, everyone got it? Have any doubt?
No, sir.
Yeah, go ahead. Yeah, yeah, very good. Yeah, your voice is not clear. Please, once again.
Sir, then in the second case, the data is negative, no, sir.
Yeah, second condition negative. Why? Because so from the M2, so here M1 is just gradually. So here reference frame is object, not M2. If you consider the M2 as reference frame, you will get the different answers. Okay. So don't confuse this point. So here object acts as a just a simply frame of reference, like a fixed point. With respect to object, I just develop these two notations. Develop these two notations. So in the second case, what happens if M1 moves away from the M2? So from the M2, just M1 just moving. M1 just moving. With respect to just object, you have to consider distance gradually decreases. Just if you are confused like this, if you are just confused like this, so if you consider just a distance from the M2 to object, you will get the positive value. That is completely and absolutely wrong approach. Don't be confused this point. That's why initially I just stressed that point. Here object acts without object. How can you talking about just massive bodies? How can you talking about just displacements? That is not correct approach. Okay? Yeah, okay. Should be clear?
Madam,
No response.
Yes, sir. Clear.
Yeah, okay. Can I give the one problem based on this one? So in this situation, just identify one important point that is very useful to solve the problems. What is that important point? So try to understand this point. In the given illustration, center of mass is always fixed. Am I right? Had any doubt? That means center of mass does not change. Who are just changing? masses are simply displaces, but center of mass does not change. Center of mass is always fixed by this relative motion. If center of mass is fixed, what happens? Delta HCM must be equal to 0. Is it okay?
Yes, sir.
Got it. Okay, right. Very good. Now in this situation, can I give the problem? I'm stressing this point also. Delta HCM equal to 0. Why? Center of mass.
Is
Center of mass
constant.
Center of mass is always fixed.
does not change. That's why delta
HCM
HCM equal to 0. Delta HCM equal to 0. Right? Delta HCM equal to 0. Right?
Yes, sir.
Okay, right. And coming to the just, I want to give one a small problem related to this one. Right, one example. Take this is one massive body like 10 kg. This is 10 kg massive body. And coming to the next one, no? This is like 30 kg body. Just have to assume. Just two bodies. Any two bodies, no problem at all. Just to take two bodies. Now these two are separated actually. Separated with different displacements. Now here, just my question is, please write up. I want to give the just a question now. Okay. Please write. Can I dictate the question?
Yes, sir.
Yes, sir.
Yes, sir.
10 kg mass. 10 kg mass moves by 10 kg mass moves by 10 kg mass is moves by 2 centimeter 2 centimeter moves by 2 centimeter towards M2. Sorry, towards M2 means here towards 30 kg towards 30 kg towards 30 kg towards 30 kg. Then find how much displacement moved by 30 kg moved by 30 kg. Can you solve?
Yes, sir.
Yeah, try to solve it, please. First.
So delta x2 equal to minus 2 by 3.
Delta x2 equal to minus 2 by 3. Yeah?
Yes, sir.
Okay, I will check it. Don't know the answer actually. Okay, let us verify. Remaining children, are you solving?
Yes, sir.
Yeah, okay. What is the answer?
2 by 3.
Sir, 2 by 3.
Minus
Sir.
2 by 3.
2 by
2
3.
by 3.
2 by 3, yeah? Okay.
Yes, sir.
If any just 3 or more members' answers are correct, that should be correct. Minus, okay, I will give. Now here, according to given problem, delta HCM equal to M1 delta X1 plus M2 delta X2 whole divided by M1 plus
M2.
M2. M1 plus M2. Now here this is 0. I said already the point. So M1 already there. N into
10 into
X1 2 plus M2 into M2 means 30.
30.
Into
X2.
just delta X2 value. Delta X2. So what is the
40.
total mass? 40, 40 kg. So simply this one cancel. 0 equal to 20 plus 30 delta x2. Right? Just I need this delta x2 value. So therefore, yes, exact. Delta x2 equal to minus 2 by 3. Yes, very good. So what is the meaning of this sentence? What we notice from this sentence?
2 by 3 away from the M2.
Minus means moving away from
Direction.
the
Towards
From
negative.
the away.
right on that. 30 kg mass, right on that point. Please add that point. 30 kg mass should be 30 kg mass should be moved towards left. అంతేగా? Left. Move towards left by 2 by 3 centimeter. 2 by 3 centimeter. Right, very good. Next, one more
Minus
problem.
2 by 3.
Minus 2 by 3. Yes, very good. Here minus represents towards left
Left.
and move towards the object. 10 kg body. Yes, one more problem, please. This is a like parallelogram. Like parallelogram. Like parallelogram. Now here I consider this distance equal to A, this distance equal to this side equal to B. So masses of these four arms equal to M, 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 and M. To draw the just right angle to the just given surface, this is one side. Again, just to draw the right angle to this given surface, this is one more side. I consider the just angle of inclination equal to theta. This one also theta. Right? This one also theta. Now here, this is the total. This is the total length equal to A. Now this is B means what about this one? B cos theta.
Theta.
Components. And coming to the next one, this is B
B sin
sin.
theta.
Similarly, this one also B. This is also B cos theta. And
B
this is
sin
the
B sin theta.
First of all, I want to develop the coordinates of the different masses. But in this case, all masses are must be equal. Right? Just I want to develop the coordinates. Now this is at origin. So origin means like
0, 0.
0, 0. And coming to the next one. This is second massive body. Second massive body. So what are the coordinates of this one actually?
A,
Coordinates.
0.
A, comma 0.
A, XA, Y,
0.
0. And coming to the next one. What about this one? Here, this is A. This is B plus cos theta. So simply, what about X value? A plus B
B
cos
cos
theta.
theta, comma sin theta, B sin theta.
Yes, very good. B sin theta. And coming to this one. B cos theta, B sin theta. B cos theta, B.
B sin theta.
These are the coordinates of four masses of parallelogram. Parallelogram. Can you find out the just coordinates of HCM and YCM? Can you find out? Go for the just HCM and YCM. Please try to understand. Solve it, please. HCM and YCM. Everyone, please involve in this. Are you trying? No one responds.
Yes, sir.
Okay, please solve it.
XCM equal to A plus B cos theta by 2.
Very good. Okay, next. Coming to the next YCM.
Sir, XCM is A plus cos theta by 2. The YCM equal to B sin theta by 2.
YCM equal to
B sin theta by 2.
Yes, sir.
okay, very good. Okay, XCM equal to okay. Okay. Remaining children, please check it, please. Yeah, your answers are correct. Very good, very good. Now coming to the next one. So just to distribute the values, you'll get the answers. Now XCM equal to, so for massive particles are there like M1, X1 plus M2, X2 plus M3, X3 plus M4, X4. Substitute the masses, you get the answer. So like M1 plus M2 plus M3 plus M4, X1, Y1, X2, Y2, M1, S1, this is 0, M into 0, plus M2, mass M,
M into A.
A, plus M3 also M. What about X3?
A plus B
A
cos
plus B cos theta.
Cos theta, very good. Plus, what
B
about
cos theta.
MB cos theta.
Cos
B cos
theta. Yes, very good. B
by
cos
4M.
theta. 4 mass means 4 into M.
4M.
Here, this one cancel as 0.
MA plus MA plus MB
Not
cos theta.
cancel. So simply remain term. A plus B cos theta, A plus B cos theta plus
B
B
cos
cos
theta.
B
theta.
cos theta.
Cos theta
By 4.
4 by 4. So what is the final answer? Like
2A
2A.
2A
2A plus B cos theta.
by 2 A plus B cos theta by 4.
4.
So finally what is the answer? Like
A
Cos
plus B
XCM
cos theta by 2.
take 2 common. Now A plus B cos theta by 2. Jagdish Kumar, please unmute yourself. Unmute options are available.
Sir,
Yeah.
I am chemistry faculty, sir. Next I will come. Just I raised the hand. Okay, you can continue, sir. Time is there, no problem.
Sir, Jagdish sir.
Sir, నేనే పర్లేదు. Just 5 minutes before I came just.
Okay, sir. Okay, sir. Thank you.
Okay, you can continue. Yeah.
Okay. Okay, sir. Now here, go for the just YCM value. YCM value. Now, how can you calculate YCM value? YCM equal to
M1 Y1
1 Y1
Y1
plus
plus M2
M2
Y2
Y2
Y2 plus
M3 Y3
plus
Y3 plus
M4 Y4
M4 Y4
yeah,
plus
whole of
M1 plus M2 plus M3 plus M4.
M1 plus M2 plus M3 plus M4. Yeah, okay. So substitute the values. M1 equal to M. What about Y1 value? Also 0.
Zero.
The mass at the origin. The mass at origin. And coming to the next one. Next, M into what are Y2
M into
value?
0
Zero.
0
Y2 also
0
Y2 also
0
0. Yeah, okay. Coming to the next, M3 means M into Y3. What about Y3 value?
B sin theta.
B sin theta.
B sin theta. And coming to the next, M into last
sin
one.
B sin theta
B sin theta.
By 4M.
B sin theta.
by 4M.
By 4M.
So by 4M. Yeah, okay. Now
M plus sin theta plus M plus sin theta by 4M.
denominator. What is the final answer? B sin theta plus B
B
sin
sin theta
theta.
plus B sin theta.
2M B sin theta by 4M.
4 divided by
4.
4. The final answer. B
By
sin
B sin theta by 2.
And theta by 2.
So what are the coordinates of HCM and YCM?
A plus B cos theta.
Yeah, A plus B
Cos theta by 2,
Cos
comma,
theta by
B sin
B
2,
sin
B sin theta by 2. Yeah, please write. So verify the answer. Okay. So this is about position vector of center of mass. Position vector of center of mass. Coming to the next one is methods of. Can you have this one?
Yes, sir. Yes.
Next concept is very important. That is methods to just I want to introduce this one. Methods to locate center of mass. To locate center of mass by different methods. First one is what is the first one? Very important. This one, method of symmetry. So this is completely based on the mathematical concept. Jaydeep sir, can I stop it?
No problem, sir. You can.
Just within 1 minute. Just I want to close.
Okay. Just for co-hosting, I'm raising my hand. Okay, now.
Okay. Sorry for the your name, sir. Okay. Method of symmetry. Coming to the next one. Method of decomposition. Next one is the method of decomposition. And the third one is this is the ultimate method in the center of mass. So this is the method of integration. So these three are very important methods to develop to locate our center of mass. Okay, just one by one, just we are going to discuss coming days. Okay, thank you, children. Have any doubt? Completed portion, uncompleted portion.
Okay, sir. Logra sir. Thank you, sir.
Sir,
Thank you, sir. Thank you, sir.
Jaydeep sir, extremely sorry.
Okay, sir. Jagdish sir, can you raise your hand, sir? Jagdish sir.
Sir, from 15 minutes onwards, I'm raising my hand. You are not
Okay,
seeing.
okay, sir. Okay, sir.
Yeah. Okay.
Okay, sir. Jagdish sir.
Okay, sir.
Okay, sir. Carry on, sir.
Yeah. Okay. So I think I'm audible.
Yes, sir.
Yes.
Yeah. So in the last class we discussed homologous series in organic chemistry here. So now today we are going to discuss another subtopic. Yeah. First of all, regarding degree of carbons, we are going to discuss today. So degree of carbons, and how can you say the carbon, which is the degree of carbon. So here degree of carbons means generally 4 types of degrees are there here. Based on the number of the carbon atoms attached here, we can say the degree. So here majorly this carbon having generally 4 types here. First one, primary carbon. So second one here, secondary carbon, and tertiary carbon, and here quaternary carbon. So quaternary carbon. So what is the meaning primary, secondary, tertiary, or quaternary? Here primary means just we are representing like this here. secondary, tertiary, and here quaternary degree. And first of all, primary carbon. So how can we say, is it primary carbon or not? So here, primary carbon. So primary carbon means if any carbon which is directly connected with one other carbon. Okay, if any carbon directly connected with one other carbon, so then that carbon is called here primary carbon. For example, just I'm showing here. So I'm taking two carbons here. So I want degree of carbon of the first one, first carbon. What is the degree of this carbon? I rounded just here. So we have to say the degree. So first of all, this carbon, what we selected. So the carbon attached with how many carbons around it? How many carbons are there? Only one carbon. It is.
What?
So one carbon means, so this carbon attached with only one carbon. So it is called primary carbon simply. Very simple thing here. When carbon directly connected with only one other carbon, so then that carbon is called here primary carbon. Now you can ask one thing here. Here one doubt we can erase. What is that here? If carbon attached with all our hydrogens, but no other carbons are there. So this one also we can take in as primary carbon only. Even it is not connecting to the other carbons. But in some books they are giving super primary carbon also we can say here super primary carbon. But generally we can say primary carbon also along with. So this is about primary carbon, how we have to identify. Now, just in this example only I given here, second carbon is there. What about this one? If I'm asking the second thing, this one, what about degree of carbon? It is also primary. Why? This carbon connected with this carbon. So even first carbon connected with one carbon only. Second carbon also connected with first carbon only. So one only. So both are primary carbons. We can say this. Okay. So this is about primary carbon. So how can identify here? The carbon which is directly connected with only one other carbon atom is called here primary carbon. Now secondary carbon next here. Simple thing here. These are all. So secondary carbon means what? So in the name only is there. If the carbon directly connected with two other carbons, So if I'm taking one carbon, if it is directly, directly connected with two other carbons, then it is called
Sir,
here.
can you repeat the definition of primary carbon?
Yeah. Just I'm telling that only. If I'm taking this example, the first carbon belongs to primary only because this carbon connected with only one carbon. Second carbon belongs to secondary, and third carbon belongs to again primary because this carbon connected with one carbon. First carbon connected with one carbon, but middle carbon connected with both carbons, two carbons here. So that middle carbon belongs to here secondary carbon. Now, if I am taking CH3, CH2, CH2, CH3, I am taking this compound and I want first carbon degree of the first carbon. What about this one? Primary. Why? Because this carbon connected with only one carbon. But what about second one? This carbon connected with two carbons, this carbon and this carbon. So it is secondary. And what about third carbon? This carbon also connected with carbon. Secondary. And last one, it's carbon connected with only one carbon. Primary. Simple. Yes. And this one also next to the tertiary carbon. So same. Tertiary means here if the carbon directly connected with three other carbon atoms. Now I will give one compound here. That means here simply we can say like this. If one carbon which is connected directly with the three other carbon atoms, then that carbon is called here tertiary carbon. The remaining three are primary one. Okay, primary carbons only. So if I'm giving one example, I'm taking here, you can say each and every carbon degree. We can explain here. So see this example. From left to right, we are going to discuss about the degree of carbons. From left to right means, So I'm underlining that carbon. What about this carbon degree? Degree of this carbon is always what?
Primary.
Primary, because it is
Primary carbon.
so if you see the underline this carbon, second another carbon I underlined now.
Three.
So
Secondary.
it will be
Tertiary.
one,
Tertiary.
two, three carbons. So
Three
this
carbons.
yes,
3 degrees.
yeah, it belongs to the tertiary carbon. And next this one, both sides
2
two
degrees.
carbons are there.
2.
Secondary carbon.
Secondary.
Secondary carbon. This one again,
Secondary
Oh,
carbon.
3
now
degrees.
Tertiary.
three carbons
3
are there here.
degrees.
1, 2, 3. So it is tertiary. And what about last carbon? The horizontal.
Primary.
Yes, it is primary. And what about upper carbon here? This branch. It is
Primary.
Primary.
One.
what about this
Primary
carbon again? Yes,
Primary.
Primary.
thing here very easy. And next year, quaternary. Quaternary carbon means if any carbon directly connected with four other
4.
carbons. Four carbons. But so this is the quaternary carbon. Quaternary is possible for carbon. Why? Because of due to its tetravalency. It can form four bonds. So these all remaining are here primary carbons only. So I think you got clarity here.
Yes, sir.
This is about the degree of carbons here. But here we have to discuss one more thing here. Degree of hydrogen also. So degree of hydrogen in the organic compound, simply very easy thing here. At primary carbon attached with how many hydrogens? Attached with how many hydrogens? So those hydrogens are called here primary hydrogens. So primary carbon attached with hydrogens. So this hydrogens number, this number we can write here. The how many number of primary hydrogens also we can write. So if any hydrogen, when it is attached to the primary carbon, that hydrogen is called primary hydrogen. If hydrogen attached to the secondary carbon, this hydrogen is also called secondary hydrogen. Okay, that hydrogen should be attached with the secondary carbon. Those hydrogens are secondary hydrogens. If any hydrogen attached to the tertiary carbon, those hydrogens are called tertiary
Hydrogen.
hydrogen. And is quaternary hydrogen is possible or not? Not possible. Why?
Not possible.
Because carbon already, it is already having tetravalency. So tetravalency means four bonds already formed here. So there are no hydrogens bonded with the quaternary carbon because already valence is satisfied. Maximum number of covalent bonds are four only. Okay, so at quaternary carbon, no quaternary hydrogens are possible and no, not existed first of all. So quaternary hydrogens not existed here. So, but tertiary hydrogens existed, secondary hydrogens existed, and primary hydrogens also existed. Now, I will give one example, and you have to say both carbons and hydrogens, quaternary, primary, secondary, tertiary, everything here. Now, I'm taking one example here. So CH3, CH2, CH, CH3 here, and yeah, CH3, yes, CH3, and this one CH3. In this example, so I want carbons. So primary carbons, how many? Okay, secondary carbons, how many? Tertiary carbons, how many are there? Quaternary carbons, how many are there? At the same time, primary hydrogens, secondary hydrogens, and tertiary hydrogens. Quaternary hydrogen not possible. So directly we can write here about carbons here. First of all, here underlining first carbon, which is primary, secondary, or tertiary. According to
Primary.
yes,
Primary.
it is primary. And what about this one?
Secondary.
Very good. What about this one?
Tertiary.
Tertiary. And what about this one?
Quaternary.
Secondary.
Quaternary. And this carbon primary.
Primary.
Primary. Primary. So totally, how many primary carbons are there here? How many?
Five.
One. Here, 1, 2, 3, 4, 5. So 5 primary carbons. And how many secondary carbons? Only one.
One.
Tertiary, one only. How many quaternary? One.
One.
Now, at each and every primary carbon, how many hydrogens? See here. Here, 3 hydrogens. Okay, so from each and every primary carbon here, three hydrogens. So that means 15 hydrogens are there, primary hydrogens. Each primary carbon containing 3 hydrogens. Total 15 hydrogens are there. And what about secondary here?
Four.
Yes, only 2 here in this example. And what about tertiary? 1 hydrogen.
One.
So, okay. So like this here, we can,
Sir,
yes, ask.
please explain hydrogen, sir, how to count.
Simple,
Can
amma.
again explain?
Now here I am taking one example in this. Here, see here. This is primary carbon only. Okay. So this primary carbon containing how many hydrogens? 3 primary hydrogens. But those hydrogens should be attached with the carbon which is primary carbon. Then this hydrogen is also belongs to primary hydrogen. Okay. If it is primary carbon, the attached hydrogens are also primary hydrogens. If it is secondary carbon, then attached hydrogens are secondary hydrogens. Clarity here. Based on the degree of carbon, we have to explain the degree of hydrogen. When hydrogen attached with the secondary carbon, those hydrogens are belongs to secondary hydrogens. When hydrogen attached to the tertiary carbon, those hydrogens belongs to tertiary hydrogens. Clarity here.
Yes, sir.
Simple thing. Now I will give one more example. So let us see here. Already I told you regarding bond line structures before, and somewhat bigger example here. So this is I am taking like this. So just see the carefully, draw the structure again with carbons. Actually, we know at intersections and corners, according to bond line structure, we are having carbons here. Okay, just I am doing here. See the structure, skeleton I am drawing again. And here where pi bonds are there, you have to keep the double bonds here and here and here. And we know how to write hydrogens. How many hydrogens are there? First of all, this carbon attached with only one hydrogen because already 3 bonds are there around that carbon. So according to tetravalency, still how many hydrogens? One hydrogen enough. And here, what about this carbon? It requires how many hydrogens? Total tetravalency means 4 bonds. Already carbon
One
has 3
hydrogen.
bonds.
Nitrogen.
And this carbon also already is having
One
one
hydrogen.
hydrogen. One hydrogen. Here no need to keep the hydrogens because it is already satisfied with the 4 bonds around it. Even upper carbon also. And next here, this carbon again one
One
hydrogen
hydrogen.
to satisfy the tetravalency. It is already satisfied with chlorine. And here this is again attached with one hydrogen to satisfy the tetravalence. And what about this one? Here also
One
it is
hydrogen.
hydrogen to satisfy the total number of bonds 4. Now we have to see I want a degree of carbons here. And first of all, I am rounding this carbon. What about degree? How many carbons attached with this carbon? 2 carbons, huh?
2 carbons.
Left side and right side. So it is the secondary carbon. And what about this carbon? This carbon also secondary.
Carbon.
Yeah, this carbon also here
Secondary carbon.
secondary only. This carbon
Secondary
carbon. Single or double bond or single bond or triple bond. We don't want like just we are seeing how many carbons directly connected. And what about this carbon?
3 carbons.
Tertiary.
3 tertiary.
So it is tertiary. And what about this carbon again? Secondary.
Secondary.
Secondary. Here. Here, secondary. This carbon also secondary because it is chlorine, not carbon. And this carbon again secondary.
Secondary.
Again here tertiary.
Tertiary.
So clarity here. Now total. Is there any primary carbon in this example? Not there, na? Yes. But secondary carbons are there. Left side 4, right side 4. Totally secondary
8.
carbons. How many?
8.
8. What about secondary hydrogens? Secondary hydrogens here. 1, 2, 3, 4, 5, 6. Seven.
7.
7 only because it is chlorine. So not secondary hydrogens. Okay. And next tertiary carbons, how many we wrote here? 2 tertiary
Two shit.
carbon because in the between. Okay, top and bottom. And is there any tertiary hydrogens?
No, sir.
Tertiary hydrogens are the 0.
No, 0.
The double or triple bonds, we maybe hydrogens may be absent, tertiary hydrogens, because there are multiple bonds are there, 5 bonds are there. So I think you got clarity how to write secondary, tertiary, primary, even carbon and
Yes, sir.
Yes, sir.
you got clarity about this degree of carbons. So next point here, another concept here. Now I want to discuss about degree of unsaturation. So unsaturation means hardly when double or triple bond is present in between the carbons, either double bond or triple bond. This is generally unsaturated.
Sir,
Yeah.
sorry to disturb you. Can you can you briefly describe about primary, secondary, and tertiary, like half a minute?
Yeah, just now I told you here. First of all, based on number of carbons attached, we have to say 4 types of degree of carbons are there. What are those here? Primary, secondary, tertiary, and quaternary. And we have to know the meaning of primary carbon means if the carbon directly connected with only one other carbon. So those are called primary carbons. If any hydrogens are present at primary carbon, those hydrogens called primary hydrogens. Okay. And second thing, secondary means what I told you. If the carbon directly connected with 2 other carbons, those are secondary carbons. If any hydrogens attached with the secondary carbon, those are called secondary hydrogens. So same model, tertiary again. If the carbon directly connected with 3 other carbons, so that carbon is tertiary carbon. If any hydrogens attached with the tertiary carbon, those hydrogens are called tertiary hydrogens. Clarity
Okay,
here.
sir. Okay, sir.
Quaternary
Yes.
means
Thank you.
4 carbons, but quaternary hydrogen doesn't exist. Clarity. Next, degree of unsaturation. So here double bond or triple bond generally, unsaturation means just I wrote here, but degree of unsaturation, actually another name also is there for this. We can say this is called hydrogen deficiency index, another name. Here, degree of unsaturation shortcut DU they will give. Or hydrogen deficient index means HDI. Or one more name also is there. Double bond equivalent. Double bond equivalent. So, what is degree of unsaturation? Or what is hydrogen deficiency index? Or what is double bond equivalent? First of all, how to calculate the degree of unsaturation for the given compound? Generally, they are giving one compound. Just they ask the please calculate the degree of unsaturation or calculate the hydrogen deficient index or calculate the double bond equivalent. So first of all, how to here one statement is there for this. First of all, it is this degree of unsaturation. It is equal to number of moles of hydrogen, number of moles of hydrogen that must be supplied or we are adding supplied to the compound. So the compound here, then it is converted to open chain saturated compound. We have to convert into open chain saturated compound. Okay. So how many hydrogens, how many number of moles of hydrogen that must be supplied to the compound? Generally, we have to convert them into, this is important thing. Open chain saturated means what here? Open chain means generally not cyclic. Open chain. And also it should be saturated. That saturated means always sigma bonds or single bonds only. But not please keep in mute those who are, if any doubt, then only unmute. Okay, otherwise keep in mute. Soumya. Who is Soumya? Keep in mute.
Sir. Okay, sir.
Okay. If you have any doubt, then only please unmute yourself. So next year, so open chain compound, we have to convert them means, yes, we are converting into open chain. For example, here 6 carbons are there in the open chain and there is no double or triple bond should be present. No double bonds or no triple bonds. We have to convert into open chain saturated. Then how many moles required here? So how many hydrogens required? Hydrogen molecules. That number of moles of hydrogen to convert them. For example, the 6 carbons present in the cyclic, but we want open chain. So we have to add H2 molecules to convert them into cyclic to open chain saturated. Then how many hydrogens required? So or if any pi bonds are there, if any pi bond are here pi bond, then also we can add H2 molecule. Then again we can convert them into open chain saturated like this, either ring or pi bonds. Maybe anything here we have to converting into open chain saturated. Then how many moles of hydrogen required? So then this number of moles of hydrogen required to convert the cyclic compound or to convert the unsaturation compounds into the saturated and open chain. That number of hydrogens is called here degree of unsaturation or hydrogen deficiency index or double bond equivalent. Here there is a simple formula is there. So simple thing here, no need to confuse. Just I am telling that formula for calculation of degree of unsaturation. Here, if they are giving structure, if they are giving structure is given, then how to calculate here? Degree of unsaturation is equal to number of pi bonds. How many pi bonds are there in the given structure? Plus you have to add number of rings also. Rings means cyclic rings. Okay, how many pi bonds and how many rings? If you add both of these, then we are getting degree of unsaturation. Now I am giving the structure. This formula only when they are giving structures. Now I am doing C. Just see here. If I am giving this example, what you observed in this example, is there any number of pi bonds? How many are there? Here one, here one pi bond is there. Here two pi bonds, here one pi bond. Totally how many?
Four.
Four pi bonds.
4 pi
Yeah. How many rings? First ring, second ring, 2 rings are there.
2 rings.
Totally degree of unsaturation is 6.
6.
So that means 6 moles of H2 required for converting this compound into open chain saturated compound. Okay. Next, one more example. I think you know this example here, benzene. How can you say degree of unsaturation? Number of pi bonds, how many here? 3.
3.
And how many rings?
1.
1.
So how many hydrogens required? 4 hydrogens. 2 molecules required to convert it into open chain and saturated. Simple thing. Now I am going to give one more
Sir,
example.
what
Here.
is meant by rings here?
Ring. This is one ring cyclic. This is one ring. Is here 2 rings. Closed rings are comes under one ring here. Here this is one closed ring. This is another closed ring. This is totally only one ring here. There is no other ring. Ring means what here? They are in the cyclic manner. Carbons are carbons are bonded in a cyclic manner or ring. Okay.
Okay, sir. Understood.
Discussed before cyclic compounds and examples also. Now let us see this here. Here this is pi bond. This is also pi bond. So here totally this is one ring. This is second ring, third ring, fourth ring, fifth ring. Total how many rings here? 5 rings. And how many bonds here? In this ring, 3 pi bonds. Here 3 pi bonds. Here 1 pi. Here this ring 1 pi bond. Yes, here also 5 pi bonds. Total 10. So for this compound, 10 molecules of hydrogen required to convert it into open chain saturate. Now I'm giving this one ring and attached with another ring. And what about this? How many pi bonds here? No pi bonds. All are sigma bonds. So 0. Plus how many rings? 2 rings.
Two.
Total degree of unsaturation?
2.
2. Clarity here.
of hydrogen.
Yes, sir.
Now, one more example here. I'm giving like this here. In this example, any rings? No rings.
Sir.
No.
Not there here. This is just a normal compound only, open chain. But pi bonds are there. How many pi bonds?
8.
8 pi bonds. So finally, degree of unsaturation is 8.
8.
Now, I'm giving same model, but I'm giving here pi bonds like this here. Over this example, how many rings?
2 rings.
2 rings.
But how many pi bonds here? 5 pi
5.
bonds. Yeah.
7 moles. 7 moles.
Now, if I am giving, this is one model. If I am giving 3D structure, 3-dimensional. 3-dimensional means like a cube. I am giving one cube here. For this one, a small difference in the formula. This is cube. Okay, if any 3D structures are given, then one formula is there. That is here number of faces. Number of faces is equal to, you have to consider as n, and degree of unsaturation is equal to n minus 1 formula. Here, how many faces here? Top to bottom, left to right, back to front. Total 6 faces. 6. Okay, 6 faces. Now degree of unsaturation 6 minus 1. 5. Okay. One more 3D structure I am giving. Somebody is talking. If any disturbance is there, please keep in mute. No disturbance, okay, you can, no problem. Yeah. Let us see. This is also a 3D structure here. Generally, it is called, actually, this name is prismane. This is called prismane here. So, in this example here, so how many faces are there? Front, top, bottom,
5 faces.
left, right, back side also is there. Okay. So, total here,
5.
number of faces. Yes, 5. Then degree of unsaturation, 5 minus 1. How many? 4. So this is called here, yeah, degree of unsaturation for this compound here. And last and final thing, if both 3D structure and pi bonds and rings all are there, then all we have to add. Okay. Along with this degree of unsaturation for 3D structure, we have to add. Number of rings we have to add. Along with pi bonds also we have to add. Okay, we have to sum up all of this. So let us take that type of example just I'm giving. So just see carefully. And you have to see here, identify. Here, this is the cube I'm giving here, as usual. Cube we know already. But here I'm adding few more. And here also one ring I am adding here this side. And this side also I'm adding one more part, which is see carefully. Here everything is there. Cube, 3D structure is there. Pi bonds are there. Rings also are there. How many cyclic rings? First of all, here this is one ring. This is one cycle, second cycle. Here 2 cycles are attached here. So totally how many rings are there? Rings how many? 3.
3.
Not 2. Because this belongs to 2 rings here in the bottom. 2 rings here. Because 2 rings are divided by here. This line here, this bridge, like this is called bridge. 2 rings are there in this. And here one more ring. So total 3 rings. And what about pi bonds? How many?
2.
Yes,
2 pi
2 pi
bonds.
bonds. And
Sir,
according
even cube is a ring, no, sir?
Also we have to take the formula because 3D structure is there. Here n value how much here? 6 phases along with 1 here.
minus
Total,
1, 5.
yes, total we have to add here. So 5 plus 5, I think 10. Okay.
Yes, sir.
Sir,
So this is a degree of unsaturation for any compound we can do here. But up to now, we discussed when they are giving the structure, but sometimes they are not giving any structure. They are giving a molecular formula. Then
Can you
how to
explain once
say?
again, sir?
Okay, another model here, the degree of unsaturation. So when molecular formula is given, any doubt
Sir,
ask me?
can you
Soumya?
explain again that? Can you explain again, sir?
This example here already we calculated based on the rings and pi bonds. But in this example, rings are there, pi bonds are there, and 3D structure also is there. In 3D structures, based on the number of phases, we are taking formula here. Okay, degree of unsaturation. And also rings also are there. Rings also we have to take, pi bonds we have to take, and based on the phases, we are taking n-1 formula. And everything we have to add here. Okay, understood here?
Yes, sir.
sir, even the cube is a ring, no, sir.
Come again?
That cube is also a ring, no, sir.
Yeah, no. Here, if any 3D structure, if they are giving, we should not consider it as a ring. We have to take the number of phases. Okay.
Okay, sir.
Okay. And okay, if you consider like here 6 cyclic rings you are telling, but in the cube here, when you are dividing, when you are adding number of H2 molecules, one phase we have to no need to cut up here. We have to convert them into open chain saturated. Then only for 6 phases, 5 hydrogens enough. Okay. You can take one box and just cut the faces one by one. Is it opened or not? You can see here. Okay. At any 5 faces, if you are cutting, then it is converted into open chain. No need to cut all the faces. That's why here formula is n minus. Okay, that's all. Next, if an molecular formula is given, then how to calculate the degree of unsaturation without giving any structure? Then degree of unsaturation is equal to here C plus 1 minus H plus X minus N by 2. This is one of the formula when they are giving molecular formula. So C is what here? Number of carbon atoms. And H is nothing but number of hydrogen atoms. And next here regarding X, number of halogen atoms. And next N means number of nitrogen atoms. Then you can ask one doubt here. Okay, carbon, hydrogen, halogen, nitrogen. These 4 only I mentioned, but maybe other atoms also may be present in the formula. Then no need to consider that formula. Okay, if any other atoms are there, no need to substitute that about that. For example, like oxygen. If oxygen is there, no need to consider. It is like a 0 only. We are not seeing about number of oxygens. Only these atoms are present. You can substitute the value and you can calculate that. Okay, let us take one example, then you can understand. If I'm taking
Sir, what is halogen atoms?
halogen atoms, number of halogen atoms. How many halogens are there? That number you have to substitute in the place of X here. Okay.
Sir, what is the meaning of halogen?
Halogen means fluorine, chlorine, bromine, iodine. These 4 atoms are called halogens. In starting
Okay,
also I
sir.
told you. Okay.
Sir,
So,
seventh group element.
yes, 7th group elements except astatine. Okay.
Yeah.
So now if I'm giving C4H6, then how to calculate degree of unsaturation? Here carbons, first formula C. C means how many carbons here? 4
4
plus
carbon.
minus H. H means how many hydrogens here? 6
6.
plus X means halogen. Any halogen here? No,
No.
not
No.
zero.
No,
So
sir.
0. Nitrogens not there.
0.
By 2. Okay.
No.
Simple now. So 5
5.
minus 3.
Minus
How
3.
much? 2.
2.
So 2 is the degree of unsaturation. Now one more example, C4H6O, oxygen. Even oxygen is there, but in the formula there is no oxygen atoms. We are not giving any oxygen. So C4H6O here. First of all, carbons, how many here? 4.
4.
Same, we are getting same value. 6 plus 0 minus 0 by 2. Because oxygens no need to mention. Because in the formula, there is no information about oxygen. So no need to consider oxygen. So again, we are getting same value 2 on. Okay.
Yes, sir.
Okay, sir.
Okay. So this is about degree of unsaturation about this. And next year, I'm giving one more example, C6, H6, C chlorines, degree of unsaturation. And already I told you number of carbons plus 1 minus number of hydrogens 6 plus number of halogens. Chlorines are there. Chlorine is halogen. 6 minus nitrogens not there. So 0 by 2. Now 7 minus
Once.
Sir, 1, sir, degree.
7 minus 6.
7 minus 6. That is called 1. Very good.
Sir, can you say why did you take 6 plus 6?
Because here I told you in the formula, just see once here, H means number of hydrogens, X means number of halogens. Here chlorines 6 are there. Chlorine is the halogen. So 6 halogens means 6 you have to take here. Okay.
Yes, sir. Okay.
Yeah. Just remember the formula because I'm scrolling this and you better to write the formula. Okay. When I'm giving examples. And next thing here, another example I'm going to give. C6H4 ClNO. Okay, so I'm writing once again formula C plus 1 minus H plus X minus N by 2 degree of unsaturation. Simple, just we are going to substitute. Here 6 plus 1. Okay, yeah, minus hydrogens 4, halogen 1, nitrogen also 1. But oxygen's not there, so no need to consider. So simple. So here 7 minus 2.
2. 5.
5.
5, sir.
5.
Yes. So I think you understood here.
Yes. Yes.
Sir.
This is about degree of unsaturation when they're giving formula. If they are giving structure, and already we know how to do. Okay. And one more giving information about planarity. Which molecule is planar or which molecule is non-planar? Actually, here not important, but just I'm giving some information about this. Generally, planar means what? I told you already before also. When all atoms lies in same plane, and all atoms lies in same plane, those are called here planar molecules. So those are planar molecules. For example, just now already I told you about cube. Cube is not a it is a planar molecule. Why? Because this one only in the if I'm taking this box is a plane. Okay. If I'm taking this box is a plane here. So this box, first box is a plane, but other back side is not a planar. Okay, na? So this box only in the plane. That is important point here. If I'm keeping dot in the in front, so this dot is in the plane. But what about back side dot? This is not in the plane. So this molecule, this if I'm considered this one is a plane, then this dot is a on the plane, but this dot is back side of the plane. Okay, na? Or away from the plane. So I think you understood here. So this is not a planar, not planar here, this dot. But I'm considering this square. So this is a planar molecule. This dot is a planar here. So here, first of all, according to this, okay, we can say based on the diagram. But if they're giving structures, generally, what rules we can see here? If any sp3 carbon is there, we know already hybridization. I told you. If any sp3 carbon or sp3 nitrogen, then the molecule is always non-planar. even one sp3 carbon or one sp3 nitrogen is present in the given structure, and overall molecule is a non-planar. Understood here? And only sp2 carbons or sp carbons are present, or nitrogen also. Here I am telling you, all are sp2 or all are sp, or either sp2 or sp. Okay, no, there is no sp3 carbon or no sp3 nitrogen. Every carbon, if you are checking the hybridization, either sp2 or sp1 we have to get. Then in that case, that molecule is generally planar. Okay, this point understood here.
Yes, sir.
So these two very important points here, but sometimes few exceptions also are there, and I will give clear examples here. Now, first of all, I am taking one example here, CH4. Actually, here carbon bonded with 4 hydrogens. Okay, these 4 hydrogens are in tetrahedral arrangement. Tetrahedral means what here? 2 hydrogens are in plane only, but one hydrogen away from the observer, one hydrogen towards the observer. In the starting, I told you about this. So now it is planar or non-planar? First of all, this carbon hybridization is sp3. If it is sp3, it is always non. Here, how many atoms in the plane means carbon is always central atom, which is in the plane, and this hydrogen in the plane, this hydrogen also in the plane. But these two hydrogens not in the plane; they are above and below the plane. So total atoms are 5, but only 3 atoms in the plane. This point understood? These 3 atoms means in plane. These 5 atoms total. In plane only 3 are there. Clarity here. If I am taking C2H6, I am showing you diagram here. So like this here, these are away from the observer, and these are towards the observer here, and these are on the plane. Normal covalent bonds on the plane. Now, can you say how many? First of all, this molecule is planar or not planar? This is sp3 carbon. All are sigma bond. This is also sp3 carbon. Even one sp3 carbon, it is always non-planar. But here 2, so it is also non-planar. Now, how many atoms are there? Total number of atoms 8. But in this here, this side, sorry, this is not. This one in the plane, central atoms always in the plane. So 4 atoms only in the plane. Okay. And if I'm taking C2H4, just I'm giving structure like this. So here both carbons belongs to sp2 carbons. So all are sp2 only. Now it is planar molecule. And here all the atoms in plane only. Total number of atoms 6. Even hydrogens, carbons, everything is in the plane only. Clarity here?
Yes.
Okay,
Yes,
last
sir.
example.
Can
Today,
C2H6,
what about this?
sir?
So this is actually, this is the structure I'm giving. Is it planar or non-planar? I want. First of all, see the hybridization of carbons. This is sp.
Non-planar.
This is sp. This is also sp. sp.
Yes,
And what about this one? sp2 carbon. sp2 carbon. So
Planar.
all are either sp2
Planar.
or sp. So it is always
Planar
planar.
molecule.
So total 10 atoms and 10 are in planar.
Sir,
That's
sir,
here.
sir,
Yeah.
once explain C2H6 again, sir.
So here around carbon, all are sigma bonds, sp3. Around 1 double bond and 2 single bonds, sp2. Around 1 triple bond and single, sp. Okay. Even nitrogen also we can say, if nitrogen around 3 bonds, sp3, and double bond and single, sp2, and triple nitrogen with triple bond, sp. Okay. So here all atoms in the same plane. So these are all planar. Clarity here. Any doubts up to here?
No, sir. No, sir.
Okay. So we will continue in the next class remaining concept. Okay. Nomenclature we are going to start next. Yeah.
Okay, sir.
Okay, sir. Jagdish sir.
Sir.
Thank you, sir.
Okay, sir. Okay.
Okay, completed, sir.
Yeah, completed, sir. Today.
Okay, sir. Okay, sir. Thank you, sir.
Okay, master. Okay.
Okay, sir. Thank you, sir. Dear students, tomorrow we will be meet again. Good night, students. Good night to all.